All right, 2.5, section 2.5. Now, if you want to have your textbooks open to 2.5, that's great. But make sure you have your notes in front of you. We're going to complete these examples, and we're going to come up with our exponent, some more exponent laws here. All right, so what we're taking a look at today is a power of a power. A power of a power, or a power taken to another exponent. So this is where we have two exponents involved. That's the thing here with this one. So it's a little bit different than a product or a quotient, right? But on the same hand, there are some rules that we're going to be able to follow. So if you need to cut the lights back there, go ahead and do that for those of you in the back. So this over here on the left, okay, a power of a power. So notice that I have 2 to the power of 4. That's a power in itself. And then the outside here, I have also another power on the outside. So it's a power taken to a power. It's a power of a power. So when you have two exponents like that, there are a specific set of rules that we're going to follow. So let's see what happens with this first example, okay? So 2 to the power of 4 to the power of 3, or you can say that as 2 to the 4 to the 3, if you want. But 2 to the 4 to the power of 3 means that we take 2 to the 4 and we multiply that by itself 3 times. Okay, so that's what this 3 means. And if we expand that out as a product of factors there, then I write 2 times itself 4 times each time I see 2 to the 4. Okay? And this will help us figure out what our answer is when we write this as a power now. Sorry, let's get my zoom here properly. So we end up having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 2's. So the product of the power here, the power of a power I should say, is 2 to the power of 12. Okay? All right, so let's do the same thing for a few more examples. So 3 squared to the power of 4. That is 3 squared times 3 squared times 3 squared times 3 squared. We do that 4 times, which is 3 times 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 3. So that's expanded out completely. All right, now we're going to do this as examples until we can kind of, for sure see what the shortcut is, because I need you to understand when you use the shortcut why it actually works, okay? So if we count all these 3's, 1, 2, 3, 4, 5, 6, 7, 8, that's 3 to the power of 8. Okay? So 3 squared to the power of 4 is 3 to the power of 8, just like 2 to the 4th to the power of 3 is 2 to the power of 12. Let's keep going. You might be seeing a pattern here arise. This is 4 squared times 4 squared times 4 squared. Going to go a little bit quicker here now. 4 times 4 times 4 times 4 times 4 times 4. That's 3 times. How many 4's do I have? 1, 2, 3, 4, 5, 6. That's right. So that's 4 with a base to the power of 6. Okay? All right. Let's take a look. I'm going to skip this row here. I'm going to skip this row. Actually, without writing this down, does anyone have a guess as to what this power might be?
5.
Yes.
9.
The 9. Okay, so 5 to the power of 9. You would be absolutely correct. Whoops, what is that? 5 to the power of 9 is correct. So I think you guys are catching on to the pattern here. That's great. Let me do the ones with negative exponents though, because what I've noticed in seeing your work is that negative exponents still tripping some of you up. Do you have your notes? Where are your notes? Okay, get your notes out. Yeah, you need to write this down. All right? So if we have negative 4, remember these brackets here? If we have brackets here like this, that means the negative 4 is the base. So the negative has to be included. So this one's going to be negative 4 to the power of 3 times negative 4 to the power of 3. Okay. So expanded form, negative 4, and I'm going to just do brackets around each one. Negative 4, negative 4. That's negative 4 to the power of 3 times negative 4 times negative 4 times negative 4. Now, in math as well, if you don't have any symbol in between two integers that have brackets around them, just like you see here, that means multiplication. All right. So the little times x symbol means multiplication. The dot in the middle, not the period, not the decimal point, but the dot in the middle means multiplication. And if there's nothing in between two numbers that are bracketed, that's also multiplication. Okay. So there's all sorts of notation for multiplication here. So how many do we have here? 1, 2, 3, 4, 5, 6. So this is -4, keep the brackets, to the power of 6. All right. Another one, -5 to the power of 3 times -5 to the power of 3 times -5 to the power of 3. I'm going to run out of room. Times -5 to the power of 3. Whoops. One more time, -5 to the power of 3. Okay, so -5 cubed, we need to do that, we need to multiply that 5 times. So that's a 5. All right, so this one's going to be a long one, but let's write it out here, and then we'll maybe skip the next one. So that's going to be -5, -5, -5. Okay, that's this first grouping right here. Times -5, -5, -5. That's the next grouping. Times -5, -5, -5. That's the third grouping. We got 2 more to go. Times, we'll go to the next line here. -5, -5, -5. That's the fourth one. And finally, -5, -5, -5. I'm going to be tired of -5s here in a second. So that's the fifth grouping right there. So we'll count how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So this is -5 to the power of 15. There's 15 -5s we multiply. Now, hopefully you guys are understanding the pattern, all of you here now, because there is a connection between, let's say, the 3 to the power of 2 and the final exponent of 6. The 3 to the power of 5 and the final exponent of 15. The 3 to the power of 3 and the final exponent of 9. The 2 and the 3 as a final exponent of 6, and so on. 2 and 4 is 8. 4, 3 is 12. So what is the pattern? Can anyone state the pattern for me here in words? What do you do? A power of a power, what do you do? Go ahead.
You take the 2 exponents and you just multiply them.
Yes, if you have a power raised to another power, you multiply exponents to get the exponent of the final version, okay? So we're talking about multiplication. With product of powers, we add exponents. With a quotient of powers, we subtract. So a power raised to a power is multiply. Got it? Okay, so we'll skip those last 2 lines because I think you guys got it. That's great. We always have lots of examples. So state the rule. We just talked about that rule. What should we do here? The next page, okay? I think you guys on the next page, do you have this a blank there? Okay, let's fill in the blank. Exponent law for a power of a power. So here's the here's the rule written out from that we just talked about. When you have a power to a power, and remember, you just have one base shown and 2 exponents. Okay, a power raised to a power, power of a power. When you have this case, the base stays the same and you multiply the exponents. As always, the base can't be 0. We run into mathematical problems when the base is 0. But a power raised to a power, you multiply. And I think we can be thankful that we don't have to write these out every time to figure out. I'm thankful that there's a pattern that we can follow. Are you guys thankful for that as well? Yes? Okay. Some of these shortcuts. See, that's what math is about. In the real world, if you see patterns, things happening predictably, you go to math and you try and find a mathematical explanation for what you see, and then you can that's a description of patterns, and you can use that pattern to figure out other things a little quicker. So it's like, you don't have to trial and error everything. Like, 2 + 2. Oh boy, let me get my stones, and I need to grab 2 stones from the road over there, the gravel path, and I need to grab 2 more stones. I need to put them together, and then I need to count them because I don't know what the rule is for 2 plus 2, okay? Now, we have that memorized, but aren't you glad we don't have to do that? 2 plus 2. 1, 2, 3. Oh, it's 4. Oh, wow. That's great. Okay, we have rules, patterns, right? 2 of anything plus 2 of anything is always 4 of that thing. And if we have a power raised to a power, multiply. All right, let's exercise this newfound power that we have. Do you get the pun there? You like that?
That's a bad.
I'm a punny guy, I must admit.
Both of those are bad puns.
They're bad? Okay, no one's listening to you. Okay. No one cares what you say. Okay, they're great. Okay, so let's see. The base here is the base 9, is my base 9 here, or what's the base that you see here? Is it 2? It's 3. Okay, it's 3. Now listen, if you view this as 9, okay, we're not using our exponent law, but you could still get the right answer. I'll explain that in a second. The rules that we're going to use here, what we just learned, is that if you have a power raised to a power, you use the same base and you simply multiply the exponents. So that's 3 to the power of 8. Okay? So that's our shortcut. That's our rule. Now, what I said earlier, just now, if you view this as 9, guess what? If you said, this is actually 9 to the power of 4. All right? Now, is that wrong? Is that wrong? Well, let's just see. I got my fancy calculator here. 3 to the power of, and this is the power of button for some of you there, right over here, this little hat. 3 to the power of 8 is 6,561. Okay? Now, 9 to the power of 4 is the same answer. Okay? So a number can be expressed 2 different ways with 2 different powers. Okay? But again, we're trying to get away from having to evaluate these. We don't want to have to do this every time. We want to go straight to this answer. That's why we're learning this. So it's not wrong to view it that way, but this is going to be a bit of a shortcut. All right, so what's my base here? Well, this is tricky. What's my base here? I got 3 numbers. It's -7. Very good. You guys are awesome. What's the power, what's the exponent on the final result power here?
6.
Now, do I add 3 plus 2? Is that what I do? Add? Oh, no. It's a power raised to a power. I have to multiply. So what's 3 times 2? 6. Very good. Very good. Now, just one more time, just so you believe me, and just so we can confirm this. Watch this. Bracket. -7 to the power of 3 is -343. And then I'm going to square that. I actually have a squared button here. That answer is 117,649. Big number. Let's check out what -7 to the power of 6 is. What do you think it's going to be? Do you think it's going to be, what?
117,649.
117,649? Oh, good one. The human calculator. Okay. Are you believing me now? Are we okay with all this? This is good? Okay. A power raised to a power, multiply exponents, keep the same base. All right, what's my base here?
2.
It is 2, positive 2, right? This negative is outside. It's outside the fence here. So it is not going to be included in any of these powers. That negative has to stay out there. So we're just going to take that negative and we're going to drop it down there. And now I'm going to deal with just this, okay? Because the negative is not part of the power. So negative is going to be outside. I'm going to write here what? My base is 2 to the power of what?
8.
2 times 4 is 8. Okay? So the negative is not inside with the 2, so I don't need brackets. I don't write brackets around here like that. Okay? And that is totally fine. That's your answer right there. If we evaluate that, you get a negative of 2 to the 8. Because right now the 8 is only attached to the 2, which makes sense because these exponents are only attached to the 2. Okay? Questions about that? All right. All right, do these last 2 on your own, please. I'll give you a minute to do these last 2 on your own and see if you're getting it. All right, E might have been a little bit tricky. I'm not sure if you got surprised by E or if you caught that, But E is a little bit tricky because we do have power raised to a power, but we still have multiplication here for the second step. So back to D real quick. 0 times 2 is 0, so 3 to the 0 is 1. Hopefully you all got that one. This one, if you had 42 to the power of 96, I wouldn't blame you too bad because I know you're in the mode of multiplying. But here, in this step right here, I'll just highlight that. In this step right here, we have not a power raised to a power, it's multiplication. So we would add those. 6 plus 16 is 22. Okay? Did anyone get the right answers for both of them? All right. Okay. Well, not too many. I think that might have tricked some of you. Okay. All right. Well, no problem. Okay. So here, example 2, simplify first, then evaluate. Simplify first, then evaluate. So we're basically going to do everything that we did before, except at the end, let's evaluate the power to get a real number answer instead of just in exponent form. Okay. So this first value is 2 to the power of what? Okay, I multiply, so that's 3 times 2 is 6. Very good. Now I have multiply by, and again, we should remember MedMass, right? So in evaluating all of this, I need to do exponents. So these are considered the exponents. We need to take care of these first before we do multiplication. So that's why I'm doing it this way. This is 3 to the power of 4. Okay, now, not the same bases, so we can't use our fancy schmancy rules, right? The fancy schmancy exponent law rules when we have same bases, okay? Different bases? Let's see what we can do here. Okay, 2 to the power of 6. Without your calculator, who remembers what 2 to the power of 6 is? Do we have this memorized yet? Or do you have those powers in your notebook somewhere? Yep. It is 64, yes, very good. 3 to the power of 4. You should know what 3 squared is. That's 9. You should know what 3 cubed is. That's 9 times 3 of 27. 27 times 3 is? 81. Very good. 81. All right. Now, you can use a calculator for this one. Multiplying 2-digit numbers, that's totally fine. 64 times 81. What do you get? 5184 is correct. So simplify first, then evaluate. Okay. Any questions about that one? All right, do B on your own. Do B on your own. Your turn.
Okay.
All right, I just showed you 2 different ways that you could kind of do this. Watch carefully. Watch carefully. You should get the same answer whichever way you did it. The answer here for the second one is 729, positive 729. So over here on the left, okay, I did the exponent power of a power rule. 2 times 3 is 6. So I got negative 3 to the power of 6. Make sure there's no brackets around the negative 3, technically, okay, because there's no brackets inside here. And then over here, negative 3 to the power of 0 times 9 is 0. So a negative times a negative is positive. But our rules here would say, hey, I would add 6 plus 0, so negative 3 to the power of 6, which is positive 729. So that's one way to use the rules here, right? Like this. Whoops. My program might be shutting down here. Give me a sec. The other way to think about this is to evaluate inside the brackets first. If you're evaluating, it says simplify, then evaluate. But if you were to evaluate first, notice that this is actually a negative 9, and then to the power of 3. And this is actually negative 1 to the power of 9. So this is another way you can do it. This is not simplifying first, but that's another way you can look at that. It should give you the same answer. All right, any questions about this? I'm going to give you some practice here now because math, you get good at math by practicing, just by doing it over and over, training yourself to kind of do the right things. Show your work, pay attention to signs and rules. So here's what I'd like you to do for your assignment here today. Number 6, number 7, number 9, 11, 12, and 13, E and F, please. So that's 2.5 assignment part 1. That will be on the website as well, MrMathWell.com. You can check that out as well as this video is going to be up there soon. Mhm. Yeah.